This is the homework for 636, 37, and 38. In problem 636, you need to write directions to translate the original triangle to make the new triangle. So here's the original triangle, and we have to describe how you went from here to here. So there are several ways of doing it, but one way, and remember translate, think of transliding, you're sliding the figure. So I'm going to translate 2 units to the right and 3 units down. So this vertice, the bottom of the triangle, to the bottom of the triangle. Translate 2 units to the right and 3 units down. And you would do that for each vertice. 2 units to the right, 3 units down. The other way is you could go 3 units down and 2 units to the right. Either way works. And this is what it would look like using patty paper. Line up the origin cross, trace it, and I go 1, 2, 3 units down, 1, 2 units to the right. For part B, what are the coordinates of the vertices of the new shape? So these are the vertices of the new shape, and we have 0, 0, -1 on the x, 0 on the y, so -1, 0. And the third one would be -1 on the x and -2 on the y, so -1, -2. For C, on your graph reflect the original triangle across the y-axis. So here's the y-axis. And anytime I'm doing reflecting, I always want to highlight the axis that I'm reflecting over. So I know it's going to jump over to the other side or flip to the other side. For reflection, one way is just to count the vertices and how far they are from the axis that you're reflecting over. So they need to be equidistant. So this vertex is 1, 2 units to the left. So this would be 1, 2 units to the right. This vertex is 1, 2, 3 units to the left, 1, 2, 3 units to the right. 1, 2, 3 units to the left, 1, 2, 3 units to the right. The other way is by using patty paper. Line up the origin cross, trace it, and you're going to flip the patty paper over the y-axis. And there's our reflected image over the y-axis. Now, what are the coordinates of the new triangle? So we have 1, 2, 3 on the x, +1 on the y, so 3, 1. We have 3, 3, and 2, 3. For 637, you need to make a table and a graph for the rule y equals -3x + 1. The -3, that is the slope or rate of change. +1 is the y-intercept or the initial value. So in order to graph this, we take the y-intercept, and I highlighted it yellow with the y-axis yellow because this is where it intersects the y-axis at +1. From there, we use the rate of change or slope. The slope is -3, and I can write -3 as a fraction as -3/1. The reason why I wrote it as a fraction is because then I have it as rise over run form. So from my y-intercept, I know I'm going to rise -3, which means I'm going to go down 1, 2, 3 and run +1. Or I can do +3 over -1 because +3 divided by -1 is still -3. So negative 3, positive 1. Negative 3, positive 1. Negative 3, positive 1 has a constant rate of change. For putting it in a table, I just chose the values negative 1, negative 2, negative 1, 0, 1, and 2. And so I chose 0 and a couple of negatives and a couple of positives. You could choose any values you want, but these are just easy numbers for me to plug it back into the equation. So I'm going to evaluate these values. If I plug in negative 2, negative 3 multiplied by negative 2 is 6, plus 1 is 7. And I would do that for each value, x value. Negative 3 multiplied by negative 1, because that's what x is 3, plus 1 is 4. Negative 3 multiplied by 0 is 0, plus 1 is 1. And I did that for the last two. Problem 638, you need to solve the system of equations by using the equal values method. So you can use the equal values method as when you have the same variable isolated on one side of the equation. So if a equals 12b plus 3 and a equals negative 2b minus 4, well, if this is what a equals, I can plug it into this equation because that's what a equals. So now I have, instead of a, I have 12b plus 3. Now I solve for b. I want to get the variables to the side that has a greater value, and 12b has a greater value than negative 2b. So the inverse property of subtraction is addition. So I add 2b to both sides, created a 0 pair. 12b plus 2b is 14b. My goal is to find out the value of b, so I need to get rid of positive 3. Inverse property of addition is subtraction, so I subtract 3 from both sides, 0 pair. Negative 4 and negative 3 equals negative 7. Still don't have b by itself, so 14 multiplied by b, inverse property of multiplication is division, and I'm going to divide by 14. That creates the giant 1. What you do to one side, you do to the other. So now I have b equals negative 7/14. Negative 7/14 simplifies to negative 1/2. So now I found the value of b, so I need to now find the value of a. And I can do that by substituting the value of b back into the equation. And here's the original system. I could choose either equation to substitute it back into. But I'm going to plug negative 1/2 in for b. So I have a equals 12b plus 3. Well, b, we said, equals negative 1/2. So now I have 12 multiplied by negative 1/2 plus 3. So positive multiplied by a negative is going to be a negative. And half of 12 is 6, so it's negative 6. Negative 6 plus 3, I have more negatives than positives, so I know it's going to be a negative. Signs are opposite, so I subtract. 6 minus 3 is 3, so a equals negative 3.